started by introducing our graduate teaching assistant, Sada. And then we talked about the two different types of data, which is quantitative versus qualitative. And we mentioned also the difference between ordinal qualitative and nominal qualitative. And we say ordinal qualitative refers to a category where there is an order implied, right? Such as the ranking in terms of education, freshman, sophomore, junior, and senior. And then for nominal qualitative, there is no order implied in them. So it's such as color or our name or regular names or names of states. So then we looked at this example here in the table, and we saw that we're able to distinguish between each of those variables. And we say the columns here refer to a variable or a field, and the rows we call them observations and we call them records. Okay? And then we talked about mnemonics. We say for nominal variables, if it is associated with a name, kind of helps us kind of to say that's nominal. If it is a name, there is no ranking implied or order implied, we call it nominal. If it is a category and order is implied, we call that ordinal qualitative variable. And then we went through those examples, and you all answered those questions. And again, we will move on. So let's look at this question, and I want each one of you kind of to keep that in mind, what you think, and maybe we can ask our new comer to tell us what you think about this variable. So we have a variable called order priority, whether it is high, medium, low. So would you say this is a quantitative variable? And quantitative variable, we say it's a variable where we can multiply, we can calculate, we can multiply, we can add, we can deduct, we can divide, right? And for qualitative, we said we have two types. We have the ordinal qualitative, which is categorical, but it implies order with that category. Okay? It implies ranking or order. And then the other type of qualitative is there is no ranking. It's just a category with no ranking. So based on that, what do you think this one would be?
I can say the wrong way, but is it quantitative?
So quantitative would be if the variable has numbers and we can calculate, right? So this one will not be able to calculate, for example, medium times.
So then it's qualitative.
So it's qualitative.
What is ordinal again?
So ordinal is there's order in the values.
See that one? Because there's high, medium, and low.
Okay, excellent. So it is ordinal because there is an order implied in the values. There is low, medium, and high. Perfect. So now we are set with this. Now let's move on to the foundational blocks of data visualization. So again, our brains, or 70% of the sense perceptors are actually in our eyes. So 40% of our cerebral cortex is involved in processing visual information. So in other words, our eyes helps us with understanding, right? What we see, and that's exactly what we all say. When I'm trying to say something and you say, yeah, I see, meaning I understand, right? So seeing is basically helps us understand things. And that's the saying that we say seeing is believing, right? So long-term memory is very important. And therefore we want, and also the working memory is limited. Therefore we need to divide information into chunks. So you might have heard like seven, the rule of 7 ± 3. So you might have seen in the Bible, it mentions the seven heavens, right? The seven seas, the seven wonders of the world, the seven, so there are so many sevens, whether it is in the Torah, the Gospel, or the Quran. So they always have those seven as a magic number. So seven, people can memorize up to 7 + 3 - 3. And that's why the numbers, the phone numbers, when I ask you, what is your phone number? You will tell me 956, 3 chunks, so you divide it into chunks. 620, 340, 0888, right? So you divide those into chunks, so you help that short or the working memory to memorize this information. So again, visualization help us consolidate that large amount of information. Remember last week when we were talking about that data set, and I told you how many sevens do you think we have in that data set? So if you are going to process that information manually, it will take you maybe hours to go and count every number, how many, and then you will tally them, and every number, and you put it there. It will take you hours, but visualization, when we put it in a graph, and you saw that the bar graph showed us 7, 17, right? So that helped us kind of organize and visualize that information, consolidated that complex information for us, or data. So we also talked about pre-attentive attributes, remember? And remember that Burton is one of the scientists or the scholars who introduced for us the pre-attentive attributes. And we said that the pre-attentive attributes helps our brain processes information within 250 milliseconds when it is looking at that pre-attentive attributes before it starts focusing on any other information. So pre-attentive attributes help us focus and figure out, or to help us kind of we notice, or we pay attention to that pre-attentive attribute within 250 milliseconds before we start processing any other information, right? So pre-attentive attributes includes shapes. So if we have a shape that is different, our attention will go directly to that odd shape, right? So that's what we mean by pre-attentive attribute. Before we go through anything else, right? Shapes, orientation. Yes. I have. There wasn't a good somebody to get. Okay, but probably need to speak out of the fire so they can hear you. Okay, yeah, I'll try to be closer here. Today, yeah, I'll try to be closer here. So the other thing is, so shape, orientation. So remember when we saw the italized number, when they are all fine except for one, we pick that number, right? Color, all black color in that shape, and then we have red color, right? We all want to look at that red color. Size, value, texture, right? And then there are additional ones which were included, like the position, like the coordinate that we talked about, and the order helps us as well as pre-attentive attributes. Then there were additional 3 ones, which includes motion, medium, and context. So let's have a look at each one of those. So shape, remember now we talked about the different types of data. We said quantitative versus qualitative. So you might hear me saying maybe continuous versus categorical. Those are the ones that I personally prefer to use. Continuous for quantitative, categorical for the other two. I just summarize it as categorical, right? So for shape, now we notice that we have shade, we can always spot it. And shade, as a pre-attentive attribute, we can use it to compare quantitative or qualitative variables, right? If we have qualitative variables, we can use shapes for that. So orientation, we can also use it when we are comparing qualitative or categorical variable. Color. So we can use color. In this particular use, we are using it to highlight a particular category. So again, for qualitative or categorical value, we can use color in this aspect. So colors, they have different uses. We can use it in different ways. And I have provided you with more color in the readings. But this is what we call it, the color wheel. So the color wheel, we have 3 primary colors and we have 3 secondary colors. So the primary colors are the yellow. So the yellow, the red, and the blue. Those are the primary colors. Right? And then we have the secondary colors, which includes the green, the orange, and the purple. Okay. So they are also provided to us here. So this is the primary color, the red, the blue, the yellow, and then we have the orange, the purple, and the green. Those are the secondary colors. And in between, they are just basically a mix of both. So for example, blue violet, it's a mix of blue and purple. Right? And then the light green is yellow and green. And so you got the idea for color. And we will use color a lot in data visualization, so we need to know. And this is the most important slide when it comes to colors. Based on what we have learned about categorical versus continuous variables, when to use each of those. So Tableau provides us actually with the ability to use some of those features when it comes to the use of color as sequential starting kind of, in other words, it is the saturation or the intensity of the color going from light all the way to very dark or as it is in the first one. So if we have a continuous variable, then like a continuous variable like sales, for example, right? We can have 0, meaning almost no. We can maybe have it as white here for 0. And using the yellow, the blue color, all the way to the darkest color of blue, right? So we use that sequential color when we have a continuous variable or quantitative variable, right? So then we use divergent color. So divergent color is when we have a middle point in our variable. So a variable with a middle point would be profitability, profit, right? So the profit, we might have negative profitability, we might have positive profitability. The middle point is 0. That means we didn't make profit, we didn't lose money, right? So again, when we have the middle point, or sometimes we are comparing based on the average. So the middle point can be the average. So for example, if I have a map of the United States and I want to compare the states based on the average obesity. Let's say the obesity in the United States based on state, what is the average? Let's say we have an average, and then I will show every state whether they are above the obesity in different color. As we can see here, we have divergent colors. We have blue and we have red, right? So one is above, one is below. So if it is above the median or the average, then it's going to be blue. Below, it's going to be, for example, in this case, in red, right? So we get the idea now. So the first, the sequential and the divergent, they are for continuous variables. First one, when we don't have a middle point that we want to refer to. Second, the diversion is when we have a middle point. Right? So for the rest, they are for categorical value. So it's from its name, categorical. That means we have just different colors just to distinguish. Let's say, like, oh, this is a blue color, this is yellow color, or this is state of Texas, this is state of Oklahoma, but we don't mean to just to compare them, just to distinguish and spot them quickly, right, with different colors. And then we have highlight. So we use color. Everything, all values of that category, they are in the same color except for one, so we can highlight and spotlight, shed light on that particular value in that category. The same thing also for color, we use it, especially the red, yellow, and orange. We use those for alerting, for warning, right? Especially in the United States and the Western countries, the red color is considered bad, right? Based on the cultural connotations or cultural values, right? But if you go to China or Russia, red is not bad, right? Because communism, actually their flag is red, right? Or socialism. So those are cultural things, so we need to keep in mind, right? When we are using those colors. So again, this is an example of how they use color to distinguish categories. So here they are categorizing, every category is a quarter of the year, so they put colors, although it's not a good use of color, and we will talk about the use of color later as well. So again, color as a value. Earlier, remember when we had the same shade, but we had only red, we used color as a highlight or as a warning for categorical value. Right? Now we are using color as a value. Remember, the value can be sequential or divergent. Sequential to make it easier. So the darker, the higher the value, the lighter, the grayed out, the less the value. So this is kind of an example of how we use color for highlighting continuous variables or for representing continuous variables. Again, from almost no color all the way to dark color that for a continuous variable. Texture, we use that to compare different values for categorical values. Right, so we have here the dark picture versus the grayed out. Size, we use size also to compare continuous variables or quantitative variables, right? So the size here we can compare, this is larger, this is lower, but unfortunately it doesn't tell us the exact difference between them. That's why when we talked about pie charts last time, we said pie charts, we are not going to use pie charts because it doesn't give us the exact difference and we can't even estimate it. But bar charts, column charts give us actually very exact, which uses distance instead of size. So position, we also can use it for continuous variable. Order is very helpful. So as you can see here, we have the vendors for insurance or health insurance companies, vendors, right, that provide health insurance for individuals. And we are ordering this graph based on alphabetical order. Is it helpful? Alphabetical order is not helpful, right? So what will be more helpful, because now we can't actually get a lot of information from this graph easily. So if I want to say, what are the top 3 vendors or providers for health insurance based on this graph? So you will need, it will take you a while kind of to go over and compare. You might miss, you might make an error, right? But if we order them descending way from the highest to the lowest, then we can answer a lot of questions. And remember when we talked about how we transform data to information in that graph last week or last lecture for business intelligence, we say from data to information, we always answer questions like what is the maximum, what is the minimum, what is the total, how many, right? We answer those questions. So in this question here, or in this graph, we can answer some questions about what are the top 3 healthcare providers or health insurance providers in this graph? We can easily answer that when it is ordered. What are the bottom three health insurance providers? Can easily answer that. What is the rank of Humana in this graph? We can easily answer that question, right? So now with this graph, we transformed raw facts to useful information that we can answer questions really quickly, right? So order is another important pre-attentive attribute that helps us kind of answer those questions. Which ones is the week?
They say knowledge is power, but how do we make knowledge powerful? Especially when that knowledge comes in the form of data. Lots of data. How do we find the meaning? Tell the story. Share the story. Infographics, where data meets design. What makes good data visualization? Take a few seconds to count the sevens in this number set. How many were there? Not sure? Now try. A simple color change makes comprehension almost instant. Color is one of several pre-attentive attributes, like size, orientation, flicker. Visual clues that the human brain processes within 250 milliseconds. Now imagine that we're not looking for specific numbers, but patterns. We can use color to show correlation, size to show quantity, or orientation to show trends. And not just data. The power of design can be used to better communicate all sorts of information. Processes, hierarchy, anatomy, chronology. Better communication through innovation. Because your message is only as good as your ability to share it.
So another important concept that we, when it comes to data visualization, is understanding the system thinking theory. So there are two systems when it comes to thinking. So there is system one and system two. We call them thinking systems, right? System one and system two. System one thinking, that is very automatic, very fast, and it doesn't require a lot of cognitive efforts. Right? And the second system is very slow, requires a lot of attention, and requires a lot of cognitive efforts. So system one is the spontaneous system that we all use, right? When we see color, we automatically see and we say this is the blue color. When we see 1 + 1, we automatically use system one to answer that question. Because 1 + 1 is very simple, very easy. We already know the answer. 1 + 1 = 2. So we use system one because it is automatic, right? As soon as we wake up, we pick up the phone, right? That's automatic, right? So that's one thing. That's why I'm dressed up today, because they asked me to do a photo shoot for an article that they are writing in Brownsville Herald about smartphone addiction. So they asked me if they can come and take pictures. So in that, when I talk about addiction, I talk about system one and system two, right? So addiction basically refers to system one. We automatically pick up our phone as soon as we wake up and we use it. When we go to the bathroom, some of us, we use it. As soon as we are waiting for someone, we pick up the phone. So that's system one. We do it spontaneously, automatic. Same thing for color and for visualizations. We make perceptions and judgment automatically using system one. But when we get into any difficulties or difficult or complex information, then we resort to system 2, right? So for example, when system 1 generates that first impression, intuition, intentions, and feeling for system 2, right? And system 2 is, again, we said it is slow, but when we see visualizations, we make impressions about certain things. And that is system 1, right? For system 2, after we make that impression in system 1, then system 2 helps us take actions. And again, remember when we said that what is the goal of business intelligence is to transform data to information and then go through knowledge. At the end, we want actions, right? So that way we can take actions to increase profitability, reduce waste, improve efficiencies. So again, it is all about the actions. It's not about the visualizations per se. Our goal is the action, right? So system 1 helps us with that visualizations to make the impression. System 2 helps us to decide what actions we need to take. So for example, if I ask you 19 times 23, so what would be that system? Would that be system 1 or system 2? So system 2, because it's very complex, right? Your first intuition will be is to take your phone or you go to an Excel and try to start, calculating, right? It's not like 1 + 1, we already know the answer, that's system 1, right? So again, this is kind of how systems thinking is used and applies to data visualizations. So again, presentations, impressions are built in system 1, which affects the actions that are taken in system 2. So next, I would like to go over another very important concept, which is visual perceptions. So it is very important for us to understand first how our brains process information and how our brains and minds are wired, right? It's all about perceptions. So sometimes and many times our brains get tricked by some of those visualizations, and we will understand how this happens. So if I ask you, what is the color of the top surface versus the color in the bottom surface? So would you say that the top surface has darker gray versus the bottom surface has a lighter gray? They are different, you perceive them as different, right? So that's how our brain understands visualizations based on the background, right? So now, if I tell you that actually the surface is the same for the top surface versus the bottom surface, but because of the background, that's why, so as you can see here, they are the same color, but our brain was tricked, right? And that's how we can see our brain, sometimes they trick us based on our visualizations. So now next, so again, this is kind of to show that they are the same color. The same thing here now, data shows that the font of the data is darker than the font of the data below. And this is based on the gradient background. So based on the background, our brain perceives the difference in colors of this data on the top and data on the bottom, but they are actually the same color. So this is how it should be, but based on the background, we perceive them differently. So the same thing about this bar. So the bar in the middle, if I tell you what is the color of the bar, you will tell me it is lighter in the left and darker in the right. That's how our brain perceives this shape based on the background. Because if you notice the background, one background is lighter than the other, And that actually tricks our brain again, telling us that they are different colors, but it is not different color. They are the same color. The whole bar is the same color. So how many colors do you see in this graph? Just throw a number. There's no right or wrong. Four? Anyone sees any other different? So they look like four. To some, they might say maybe two, right? But they are four, right? But it can be, our brain might be tricked to some extent that there might be only two, right? But let's look at the next one. This is the visual gate games, right? The visual deception, we can say, right? So as you can see here, this kid looks very small in this graph or in this image. But in this image, he looks very big. Look at the difference between the first one and the second. And this is also visual deception. And the same logic is like the Washington Monument. So if you go to Egypt, they will tell you, if you go to visit, for example, the pyramids, you will find those people who you will take a camel or a horse, they take you around, they'll tell you, okay, let's do panorama. So that's what they told me when I went there. I will take you panorama pictures. So they will take your phone and they will tell you to jump while they are sitting, so to show that as if you are jumping above the pyramids, right? So that's also visual perception is like the same here. Because of distance, we see things smaller and people think that, yeah, that's a trick, right? And this is kind of the explanation for that room that we saw when the child was in one corner very big and the other one was very small. So this is kind of basically the explanation for that visual deception. So how about this one? Do we all agree that we see that the top bar is much larger than the bottom? So we are all in agreement. So based on that background, actually they are not the same. They are not different sizes. They are the same size. But because of the background of the track here, it's far. It is showing that the top one is larger, but they are not. They are the same size. And let's see how we can prove that. So they are the same, but because based on the background, now our brain was deceived to show or to think that the one that is on the top is larger than the one on the bottom. So now we can see, if I tell you, what do you see? What do you see? Like as a letter, let's say a letter, H, right? So now we can see that we have some buttons that are stacked out and some they are pressed in. So we have only two pressed in, this one and this one. And now it gives us the impression that this is an H, right? And based on the light where it is coming from the top or from the bottom, and then we rotate it, we see the same thing, right? And again, it is all about all perceptions. But let's look at this one. So can you tell me what you see in this graph, in this picture? A hole or a crater, right? So it's a volcano crater. So what do you see now? Upside down. So what do you see? Just look at it more and then you will see. Mountain. Isn't it? We used to see it as craters. Now it's a mountain, right? So we see how our brain is tricked easily, which is true. It looks like a mountain for us, right? Let's look at the next one. So now going through this example, or what we call it the moire effect. You see that there is shimmering effect. So because we have the bars, they are very close in distance to each other, we see kind of shimmering effect, which is basically distracting to our eyes. Right? This is, we should have with this, and it is very important for us to know, this is the moire effect. We need to have with it when we are creating our own graphs. And if we add another bar, it is even worse, right? The shimmering is even worse, and it is even more distracting. So this is how it applies when we are using Microsoft Excel. Excel automatically provides us with bar chart or an example like this, a line chart. But it has that shimmering effect. You see that moire effect is evident there. So we need to remove that shimmering effect by first increasing the distance between the grid lines, right? In the increments of the axis, and graying out the color. We should not, actually, the grid lines, they should not be in dark color. If we are to keep them, we should remove them. Unless we see a reason why we should keep them, right? If we should keep them, we need to grade them out. Because the focus is not on the grid line, the focus is on the data itself, or on the line itself. Okay, this is an example how that moire effect happens when we have multiple bars very close in distance to each other. So this is, we call it the Herman effect. The Herman effect is when you look at these shapes, you will notice in the side of your eyes, there are black dots in between those squares. Did you not notice that? There are black dots, but you don't find it. You go seek it, but you see it, right? So this is what we call it Herman effect, which is very distracting. Our goal is to try to avoid such visualizations when we are creating our visualizations. Because they are distracting. An example of a chart is the unit chart that some visualization software provide us with the ability to build one. Right? We should try to avoid and mitigate this issue because it's distracting from the story we want to tell. So now the Gestalt principle, the closure dimension of the Gestalt principle. So if I tell you what do you see, what do you guys see? You see a wide triangle, right? So that's how our brain saw three Pac-Mans that they are set in a way, our brain automatically, based on experience, based on historical learning that we had, it automatically sees a wide triangle, although there is no wide triangle, right? We just see three Pac-Mans. So again, that's part of the visual perceptions. Again, here, what we see, if I tell you what you see, you will say, I see a triangle and a circle, although they are not complete, but our brain completes them automatically. So if I tell you what do you see? So in terms of letters, A. So it's either A or H, and our brain will automatically use system one will read it based on those two words. If I read it horizontally, our brain will read it like cat. If I read it from top to the bottom, it will read it as that. So that's how our brain uses system one, the spontaneous, the quick, the fast, without even thinking about it. Okay? With little thinking. So what you see is the largest number of squares. Which color has the largest squares? Just quickly, you don't have to think about it. Blue. So based on the system one thinking, our spontaneous thinking perception, we see the blue is the most common color. Although It is not. And let's have a look at how it's gonna look like. So they are all the same colors. So again, our system one, system two, that's in application right now. So again, here, what we see in the top left corner, we see groups of four, right? And we see in the rows, in the second, in the middle here, and we see columns here, right? So basically, yeah, our brain builds those organizations based on what we see. And for this one, I'd like you to look at the spot, the dark or the black spot for 20 seconds. Don't move your eyes. Just keep looking at that black spot. So in this, keep looking at it and I will explain what we are going to do. So our brain processes information, especially now when you are looking at that black dot. Our brain processes this visual information, which is the whole image, including that black spot. And it reaches a point where it stops processing it because it's the same information. It just stops. Well, it's the same information, I will stop processing that, right? So now keep looking at it, keep looking at it. And then when we move, so maybe you can look at the one in the graph here, in the slide. Let's look at the one here. In the slide, let's see. 1, 2, 3. So what did you guys see? Let's do it again. Let's have a look at it for 15 seconds. Okay. You see something at first was in color and then automatically became black and white. So that's exactly what happened. Our brain was processing that image, which has the color, and stopped processing it. As soon as we moved to the next image, it was still processing and still kept that color, this color, in the second image. And then we noticed that it was in color. Now we see it black and white. So now let's look at this other example. I want you to look at this red spot for 20 seconds as well. What did you guys see? Did you see anything?
I saw that.
What, where did it go?
What did you see?
I saw that. It's like zero.
So you saw a girl?
Yeah.
So that was your ghost, right? So let's do it again. That way we see clearly what happened. Right? Now you saw it clearly, right? So again, our brain was processing this image until it reached a maturation point, it stopped. When we moved to the blank image, the slide, it showed us the girl, right? So this is how our brains can be seen, right? And again, we need to kind of put it all together. We live in a world that is rich with data, so we need those tools to use this data, discover this data, present and discover how these things are working and ask questions through data. So we can actually improve quality of life, improve things around us, literature, have a better life, right? So how we do that? By asking questions of these data sets, by being creative, by requiring subject matter knowledge. So if you have you're working, for example, in human resource, so you need to know the ins and outs of human resource in that particular context company in order to be able to excel with that data set, with that data, right? We need to understand the context, and we need to understand the built-in rules or the best practices that we talked about. So this will help us actually, and again, software or computers or AI, right? They promise us a lot. But actually, we still need, we don't want the visual intelligence, which is using the tools per se. We need the business intelligence, right? So we need the business intelligence, which includes data, the tools. So we have the data sets, we have the tools, which is Tableau or BI, but we also want the brains, our own brains. Because AI will not be able to give us recommendations because they don't understand the context, how we live that context, right? Human aspect is still very important. So those are examples of great graphs. So this one is a great visualization. And we will be able to create some graphs like this. And again, those are graphs that are helpful because they have drill down information. So that's what I wanted to cover with you today for in terms of slides.